Hello students, today we are continuing with chapter 5 heat part 4 and we are discussing the solutions to the numerical problems. So we will learn how to convert. As you know, we have three scales in which we measure temperature: the Fahrenheit scale, the Celsius scale and the Kelvin scale. Now today we will learn exactly how to convert from one scale to another, one at a time. So the first question is, we are converting from 65 degrees Fahrenheit into centigrade. So in order to do this, you need to remember this formula: C is equal to 5 by 9 F minus 32. In this formula, if you look at it very carefully, we are finding the temperature in Celsius and we need to put the value of the temperature in Fahrenheit scale here, and the formula is C is equal to 5 by 9 open bracket F minus 32, and using this formula we will be able to convert temperature given in Fahrenheit scale into a temperature in centigrade scale. So let us substitute. C is equal to 5 by 9, and as you can see, the temperature is in Fahrenheit is given as 65. So in place of F we put 65 and then followed by minus 32. So minus is coming from here and 32 is coming from here. Now if we simplify the value in bracket, 65 minus 32 will give us 33. Now between 9 and 33, the common factor is 3. So 3 is a 9 and 3 11s are 33. So if you multiply the remaining values, so this is 5 into 11 will give us 55 divided by 3, and if you do long division, 55 by 3 will give us 18.33, and since we are converting in degree Celsius, so this will be in degree Celsius. So to recap, we are converting from Fahrenheit scale to degree centigrade scale, Celsius scale, and we are converting the value of 65. For this we need to use the formula C is equal to 5 by 9 open bracket F minus 32. In the next step we copy everything except in the case of F we will put the value of 65. We will simplify this. 65 minus 32 will give us 33. Between 33 and 9 we have a common factor of 3, because 3 will divide 9 and 3 will divide 33. So 3 times 9 and 3 11 times 33. So the remaining values 5 and 11, 5 into 11 will give us 55, and the denominator is 3. If you do long division, you will find that you will get the value 18.33 in degrees Celsius. The next question, we will learn how to convert from Celsius to Fahrenheit scale. So let's say we have a question in which we are trying to convert 37 degrees centigrade into Fahrenheit scale. Now to do the conversion, okay, we need to use the formula F is equal to 9 by 5 C plus 32. So here we put the value of Celsius scale in place of C and we do the calculation. So you can see F is equal to 9 by 5, okay, and multiplied by C. The value is 37 degrees. So we'll write 37 plus 32. F is equal to, since we cannot reduce 37 and 5, we'll multiply 9 and 37, which will give us 333 upon 5 plus 32. Now we'll simplify this by doing long division. So 333 divided by 5 will give us 66.6 and followed by 32 over here. So when you add these two values, 66.6 plus 32, we will get 98.6, and this is in degree Fahrenheit. So once again, we are converting from degree Celsius to Fahrenheit. We use the formula F is equal to 9 by 5 C plus 32. So in place of C we put the value of 37, because that's the one that's given the question. So F is equal to 9 by 5 into 37 plus 32. Since we cannot reduce 37 and 5, we will multiply 9 and 37, which will give us 333, divide by 5 plus 32 here. We will do long division and we will get the value 66.6 up to 1 decimal place plus 32. When we add these two values, we will get 98.6 degrees Fahrenheit, and that is the answer in Fahrenheit. Now, the next question, we will learn how to convert from Kelvin to Celsius. So, this is number C. We are converting 273 Kelvin to degree Celsius. Here we will use the formula C is equal to K minus 273. Now, in this formula, C represents the temperature in Celsius, K represents the temperature in Kelvin, minus 273. So, this is very simple. Replace the value of K as 273, 273 minus 273. So, you will find that the temperature in Celsius is 0 degrees Celsius. So, once again, we are learning how to convert from 273 Kelvin to centigrade. We use the formula C is equal to K minus 273. So, in place of K, we put the value that is given in the question as 273 minus 273. So, if you subtract these two, we will get the value 0. So, when we convert 273 into Celsius, we will get 0 degrees Celsius. Next, we are learning how to convert Fahrenheit to Kelvin. So, we are converting 96 degrees Fahrenheit to Kelvin scale. Now, there is no direct formula in which we can convert from Fahrenheit scale to Kelvin, but we do have a formula in which we can convert from Fahrenheit scale to Celsius scale and from Celsius scale to Kelvin scale. So, what we will do first is we will convert the Fahrenheit scale into Celsius scale by the formula as we used before in question number A. C is equal to 5 by 9 F minus 32. So, let us put the value of the Fahrenheit scale. This is 5 by 9, F in this case is 96 minus 32. Now, if you simplify the value in bracket, we will get 64, and we cannot reduce 9 and 64. So, let us multiply this. 5 into 64 will give us 320 upon 9, and when you do long division, we will get this value as 35.5 degrees centigrade. So, we have finished the first part of the question in which we converted Fahrenheit scale into centigrade scale. Now, we can use this value to convert into the Kelvin scale, and to do that, we will use the formula K equals to C plus 273. So, in this case, we simply substitute the value that we got in Celsius scale. In this case, C is equal to 35.5. In place of this C, we will put the value 35.5 and add it to 273. So, here we get 308 degrees 5, and that we get the value in Kelvin. So, starting again, as I said before, there is no direct formula in which we can convert from Fahrenheit to Kelvin scale. So, what we will do is we will do in two steps. The first step, we will convert from Fahrenheit to centigrade, and then we will convert from centigrade to Kelvin. So, the steps are, so we will use the formula C is equal to 5 by 9 F minus 32, and we will substitute the value of Fahrenheit 96 over here. Simplify this, we will get 64. We cannot reduce 9 and 64, so we will multiply, we get 320 divide by 9, and when you do long division, we get 35.5 degrees centigrade. Now, we will use the formula K is equal to C plus 273, and the value that we got earlier, C is equal to 35.5, we will substitute in place of C as 35.5, add these two values, and we will get the answer in Kelvin scale, which is 308.5. In question number 2, the temperature of milk in a glass is 50 degrees centigrade. Express this temperature in Fahrenheit and Kelvin scale. I am writing in short form here just to save time and space. So, let us see how we do this. So, in this question, the value that is given to us is 50 degrees centigrade, and that is the temperature in Celsius scale. Now, we will first convert the Celsius scale into Fahrenheit scale, which is by using the formula F is equal to 9 by 5C plus 32. Now, let us substitute. F is equal to 9 by 5 into C is here in this case 50 degrees centigrade plus 32. As you can see, 5 and 50, they have a common factor of 5. So, we will reduce that. 5 ones are 5 and 5 tens are 50. So, that gives us 9 into 10 is 90 plus 32, which will give us 122 degrees Fahrenheit. So, using the formula, we converted Celsius scale into Fahrenheit scale, which gives us 122 degrees Fahrenheit. Now, the second part, we will convert in Kelvin scale. We already have the value of the temperature in Celsius scale as 50 degrees. We will use the formula K is equal to C plus 273. So, we substitute the value of C, which is 50 degrees over here, plus 273, that gives us 323 Kelvin. So, here we have converted from Kelvin scale, from centigrade scale to Kelvin scale, in which 50 degrees centigrade happens to be 323 degrees Kelvin. Question number 3, it says the temperature of water in a bucket is 40 degrees Celsius. Find the value in SI units. Now, in this question, 40 degrees Celsius is given, that is the value of C, that is in Celsius scale. Now, it is asking us to find the value in SI units. Now, if you remember when we discussed, SI units of temperature is Kelvin. So, we will write it down, the SI units of temperature is Kelvin, so that you remember it for the next time. So, essentially what we have to do here is we have to convert this temperature that is given us in Celsius scale into Kelvin scale, and which is very simple by using this formula K is equal to C plus 273. So, in this case C happens to be 40 degrees plus 273. So, K is equal to 303 Kelvin. So, very simple, we convert Celsius scale into the SI units, which is in Kelvin, by using the formula K is equal to C plus 273. Substitute C with 40 and add them, we get 313 Kelvin. Now, in this question number 4, the average body temperature of a normal human body is 98.6 degrees Fahrenheit. A patient has a body temperature of 38 degrees centigrade. So, we have to determine, does this patient have fever? So, the normal body temperature is 98.6 degrees Fahrenheit, and as you know, if a temperature is above that temperature, you are generally known to have fever. If a temperature is equal to 98.6 or slightly lower, you are normal. So, now here what we have to do is, since the temperature is given Celsius scale and we do not know what is the temperature of what is the value of the temperature in the Fahrenheit scale, we need to convert this and then we will compare it with this value to find out whether this patient has got fever or not. So, here in this question what is given is the temperature in Celsius scale is given as 38 degrees centigrade. So, we will use the formula F is equal to 9 by 5C plus 32 to convert this temperature into Fahrenheit scale. So, this will be 9 by 5 into 38 plus 32. Now, we cannot reduce 38 and 5. So, we will multiply that and we will get 342 divided by 5 plus 32. And after we do long division, 342 divided by 5 will give us 68.4, in which we add 32, and our temperature in Fahrenheit scale is 100.4 degrees Fahrenheit. Now, if you this is the temperature of patient in the Fahrenheit scale. Now, let us compare. So, as 100.4 degrees Fahrenheit is greater than 98.6 degrees Fahrenheit, which is the normal body temperature, obviously the temperature of the patient is higher than the normal body temperature. So, hence we can conclude that the patient temperature is higher than normal and hence has fever. So, essentially what we did was, the temperature of the human body of the patient was 38 degrees centigrade, which we wrote here. We used the formula F is equal to 9 by 5 C plus 32 and converted the temperature into Fahrenheit scale, which we got as 100.4 degrees Fahrenheit. Now, we were told that the normal body temperature is 98.6. So, we need to compare this temperature and we found that the temperature of the patient is higher than the normal body temperature. So, since the patient's temperature is higher than the normal temperature, the patient has got fever in this case. Question number 5, it says, at what temperature will the reading on the Fahrenheit scale be double of that on the centigrade scale? So, according to question, it is saying that so let us take the temperature and Celsius scale as x degrees Celsius, okay, or simply as x, okay. And it is saying that at what temperature will the reading on the Fahrenheit scale be double. So, on the Fahrenheit scale will be double, which means that in the Fahrenheit scale will be the double of that in centigrade scale, which means that in centigrade scale it will be 2x. So, using the formula C is equal to 5 by 9 f minus 32. We will substitute the values, that is in terms of x. So, in this case c, here we have taken as x is equal to 5 by 9 and f we have taken as 2x minus 32. Now, we will simplify this and try to determine the value of x. So, first what we will do is we will cross multiply 9 and x, which will give us 9x, and the remaining part will be 2x minus 32. Now, we will expand the bracket by multiplying the values of the value in the bracket by 5. So, 5 into 2 will give us 10 and minus 5 into 32 will give us 160. Now, next what we will do is we will arrange them in such a way that x is on the same side. So, minus 60 when it comes to the left side will be plus 60 and 10x will remain here. 9x we will take to the right. So, the sign will change to negative because as is positive here. So, 160 is equal to 9x minus, so 10x minus 9x will give us x. So, let us flip this over. So, we get the value of x as 160 degrees centigrade, sorry 160 degrees. So, which means that the temperature in Celsius is 160. That means at 160 the temperature on the F scale, Fahrenheit scale will be double, which means that in Fahrenheit scale the temperature will be 2 times 160, that is equal to 320 degrees Fahrenheit. So, once again the question says that at what temperature reading on the Fahrenheit scale will double that on the centigrade scale. So, to do this we will take the value of on the centigrade scale as x, so that we need to write that as a double of that is on temperature on centigrade scale, which we will write as 2x. So, we get 2x here. We will use the formula c is equal to 5 by 9 f minus 32. We substitute, we will cross multiply 9 and x, we will get 9x. We will expand the bracket, 5 2s are 10, 5 32s are 160. We will transpose 160 to the left. So, minus 160 will become plus 160, 10x remains there, plus 9x becomes 9x, 10x minus 9x will give us x, flip it over. So, x is equal to 160. So, since we had taken the value of x as c, c is equal to x here. So, c is equal to 160. So, c is equal to 160 degrees centigrade, and f we had taken as 2x, which is 2 times x. So, 2 times x, which is 160, will give us 320 degrees Fahrenheit. So, this is the solution to this question, and you can pause the video and you can copy the solution. All right, the last question for today. So, the question says, at what temperature are the readings on Celsius and Fahrenheit scale the same? So, in this case it says the temperature in centigrade scale and the Fahrenheit scale is the same. So, let us take the common temperature as x. So, centigrade scale and the temperature in Fahrenheit scale will be taken as x. So, we will use the formula connecting the centigrade and the Fahrenheit scale, which will give us as c is equal to 5 by 9 f minus 32, and in this case we will be substituting the value of c and f both as x. So, c in this case is x is equal to 5 by 9, f in this case is also x. So, this will be x minus 32, and let us try to simplify this. So, we will cross multiply 9x, which will give us 9x here, and remaining is 5x minus 32. Let us expand the bracket. So, will give us 9x minus 5 into x will give us 5x, and 5 into 132 will give us 160. Now, let us put x on the same side. So, minus 160 will become plus 160 on the left, 5x will remain where it is, and sorry, I think let us do it the other way around. Let's keep x positive. So 9x will remain here, 5x will come to the left, so it will become minus 5x will be minus 160. So 9 minus 5 will give us 4x is equal to minus 160. So this is multiplication. On the other side will become division. So 4 into x will become 160 divided by 4. So let's reduce this. The common factor here happens to be 4. 4 1s are 4, 4 4s are 16, and 4 0 times 0. So x will be is equal to minus 40. Now from this it means that the temperature in Celsius scale and the temperature in Fahrenheit scale will be exactly the same when the temperature happens to be 40 degrees. So which means that, for the lack of space I will write here, it means that minus 40 degrees centigrade will be equal to minus 40 degrees Fahrenheit. Alright, so this is the solution. The question is saying that at what temperature are the readings in Celsius scale and Fahrenheit scale the same. So we will take the common temperatures x. So C and F both are equal to x. We will use the formula C equal to 5 by 9 F minus 32. Substitute both C and F as x each and simplify. We will cross multiply 9 and x, which will give 9x. We will expand this. 5 into x is 5x, 5 into 32 is 160. We will bring 5x to the left, plus 5x will become minus 5x. When you transpose, 5x minus 5x will give us 4x. 4 into x, when you take it to the right side, will become 160 divided by 4, because multiplication will become division on the right side. So common factor between 4 and 160 is 4. So 4 1s are 4, 4 40s are 160. So x is 40 degrees. So since we have taken the C and F is both equal to x, so C and F both equal to minus 40 degrees. So essentially minus 40 degrees centigrade is equal to minus 40 degrees Fahrenheit. Thank you.